Hello friends, welcome to the trigonometry crash course. We will first revisit some familiar trigonometric formulae and solve a few typical examples. So let's start with the formulae. Now the trigonometric functions, usually sin x, cos x, tan x, cotangent x, cosec, secant x and cosecant x, all of these are interconnected. So let's write down the formulae, how they are related to each other. So tan x or tangent x is written as sin x by cosine x. Cotangent x is the inverse of tangent x and is in other terms written as cos x by sin x. The other two are secant x, which is 1 by cosine x, and cosecant x, which is 1 by sin x. Now, though tan x and secant x are not directly, they do not seem to be related, but as we'll see how they are related to. So secant squared x is nothing but 1 plus tan square x, and similarly cosecant square x is 1 plus cot square x. Now since tan square x and cot square x, these are all real values and hence these must be always positive. So we get that the absolute value of secant x is always greater than or equal to 1. And similarly, cosecant x, absolute value is always greater than or equal to 1. Now, secant x is nothing but 1 plus cos x, as you can see. So cos x must be less than or equal to 1, and similarly sin x is always less than or equal to 1. These are some of the most general and these are just the interrelation between the trigonometric functions. Now moving forward to the ratios or of the allied angles. Now as we all know that x or the angle theta, now that can vary only from the angle has unique values over this range 0 to 360. So now what we know further that after 360 it's actually 360 becomes the period of these functions. So after 360 everything like 360, for 360 will have all these same trigonometric values as that of 0 degrees. And this is actually in degrees, not in radians. So in degrees or in radians it will be 0 to 2 pi. Hence we can write that any trigonometric say it is sine, so sine of 2n pi plus theta, that will always be equal to sin theta. So is any other value, say like cos 2n pi plus theta is cos theta. The only exceptions are tan. They are actually not exceptions to this rule. They actually have a period of pi by just pi. So tan of n pi plus theta is also equal to tan theta. And since tan is nothing but inverse of cot also follows the same rule. Whereas this one is followed by all of cos 2n pi plus theta, secant 2n pi plus theta, and so cosecant 2n pi plus theta. Now apart from these, we can also write a few other conditions on these angles, on the allied angles. Now these angles are called the 2n pi plus theta. This 2n pi plus theta And these are called allied angles because when you draw these angles on a graph, say r theta, say this is r and this is theta, so this is our r theta plot. Now here suppose this is our theta in the counterclockwise direction, that is the default. So suppose this is our theta, 2n pi plus theta, this is 2 pi, so you take one more round, that is 4 pi. So 2n pi will bring us back to this starting position, and then the theta. So the theta is actually indistinguishable. So that is why these are called allied angles. Allied angles. So these are the basic relations with them. The only exceptions are tan theta and cot theta, which actually bring back the same values after just a rotation of pi. Now there are a few more conditions or say formulae for these allied angles. Sin of n pi plus theta can be written as minus 1 power n sin theta. So actually if you put theta, say put n equal to 2 here, so this becomes sin of 2 pi plus theta minus 1 power 2, that is just 1 into sin theta. As we saw here, sin of 2 pi plus theta is nothing but sin theta. But we see that sin of pi plus theta will be minus sin theta. From this you can also derive by putting theta equal to minus theta, you will get sin of n pi minus theta, which is minus 1 power n sin of minus theta. Now we know that sin of minus theta is just minus sin theta, so this can be written as minus sin of n plus 1 sin theta. Excuse me. Similarly we can write cos of n pi plus theta, and that is equal to minus 1 power n cos theta. Now tan is just the, now see from excuse me, tan of n pi plus theta actually comes from here. Just take the ratios of sin of n pi plus theta and cos of n pi plus theta, so you get back tan theta, the formula we wrote in the previous slide. Some other formulae are tan of n pi minus theta. Now from here we had cos of, putting theta as minus theta, we see that cos of minus theta is still cos theta. Cos is actually an even function, so cos of minus theta is always cos theta. So this is still minus 1 power n cos theta. So just taking the ratio here, we get that tan of n pi minus theta is actually minus tan theta. Now the other formulae, tan, cotangent, secant and cosecant, can be, of n pi plus theta, n pi minus theta, and we just got by taking the inverses, respective inverses. So all you need to remember are these basic formulae. So sin of n pi plus theta, which is minus 1 power n sin theta, cos of n pi plus theta is minus 1 power n cos theta, tan n pi plus theta is tan theta. So that's it. The other ones like sin of n pi minus theta can be derived by just putting theta equal to minus theta. So let's now move to sum and difference formulae. These are some of the most important formulae in trigonometry, because these relate to different angles and give the trigonometric ratios of those angles. So let me write down the formula. So these formulae are starting with sin. Sin A cos B plus cos A sin B. So say A is equal to 30 degrees and B is equal to 45 degrees. Now we know that we know the respective trigonometric ratios of 30 degrees and 45 degrees. Using using the sine of those angles, sine and cosine of those angles, we can find the sine of a plus b. So this is one of the most these considered some of the most important formulas in trigonometry. Similarly, cos of a plus b is given by it is cos a cos b minus sin a sin b. So this is a place where you might get confused and you may go wrong in exams. So please do note that cos of a plus b is cos a cos b minus sin a sin b. Unlike the sine where it was plus, cos here it is minus. This is actually evident taking two angles less than 45 degrees, because cos of 90 degrees is 0 and above cos 90 it becomes negative for some time. So let's take two angles less than 45. We know that cos decreases. So like this. So it is suppose 0, this is 90. Cos goes like this. So suppose we take two angles here, somewhere say here, and we take the sum of those angles and take the cosine of that. That is actually supposed to, suppose the angle is, that is a plus b. This is suppose a plus b. So cos of a plus b is actually lesser, and that's what we are supposed to get. It should be minus here. So in a way, if you can remember it this way, or you can just simply remember the result and go ahead with the question you have. Okay. Now, so these were the sum formulae. Now let's take the difference formulae. Sine of a minus b. Actually, you can just get it by putting b equal to minus b. So you get now cos b, cos minus b remains cos b, so it's cos b. But we have sine of b here, and sine of minus b, because we are changing b to minus b, becomes minus sine b. So we get minus cos a into sine b. Similarly, cos of a minus b is found out to be cos a cos b plus sin a sin b. Again, note the slight change in the formula here. There should be plus for cos of a minus b. Actually, by the previous analogy which I gave for a plus b, cos of a plus b, you can arrive at this also. It should actually increase when you decrease the angle, because cos is a decreasing function. You decrease the argument here a minus b, so that will the actual function value will increase. So these are just for sine. The next is tan of a plus b, which can be just got by sine of a plus b by cos of a plus b, doing very little very simple handling of these functions. We arrive at the formula as tan of a plus tan of b by 1 minus tan a tan b. And similarly, tan of a minus b can be found out by sin of a minus b by cos of a minus b. Or it can just this can be found out by just putting b equal to minus b here. We again know that sin tan of b is equal to minus tan of minus b is equal to minus of tan b. So we just get this as tan a minus tan b and 1 plus tan a tan b. So please note the little changes in the formula here. If it is a plus b, if it is a plus, there will be plus in the numerator and a minus in the denominator. If it is a minus, there will be a minus in the numerator and a plus in the denominator. So these are the basic sum and difference formulae. You can derive these for even the other trigonometric ratios, chord, secant and cosecant. Actually, these are, you can derive them by taking the inverses and then just simple change, simple handling of this formula using the basic interrelation between these functions. apart from, you can, it's better to actually remember these basic formulae and use them in the exams accordingly. So let's move to the next ones. So these were you had one this function a plus b or a minus b, and you divided it, or you actually broke it into smaller angles. Now what if you have, say, sin a plus sin b? How do you write those functions? So let's focus on those now. So sin of a plus sin of b, now this is written as 2 of sin a plus b by 2 cos a minus b by 2. So in the previous one here, we had sin of a plus b, breaking it up as some other trigonometric functions or some other arguments. Here we have a sum of two trigonometric functions, and we are writing it as a product of two trigonometric functions. So this is sin a plus sin b equal to this. Similarly, we have sin a minus sin b. Now again, this is simple actually. You just put sin of minus sin b can be actually written as sin of minus b, and so actually this part can be thought of as plus sin of minus b. So it's nothing but you replace b by minus b in the first equation, and so you get a minus b by 2 cos of a plus b by 2. These are actually very simple ways to remember the formulae. It's actually better to just remember for, say, plus, and then most of the formulae actually, technically all of them should be derivable by just changing or replacing the positive ones by just their negative ones, and then writing them the whole equation again. Nevertheless, it doesn't hurt to remember a few extra formulae. Now for the cos a plus cos b. Now actually watch out for this function. This function always gives a slightly different formulae. So for sin a and sin a plus or minus sin b, we always had sin giving the same a plus b, so it is a plus b by 2, a minus b giving a minus b by 2. But cos a plus cos b will give only cosine functions. They were both sine and cosine in sin a, sin b, sin a plus or minus sin b, but here there will be only cosine function. This is cos of a plus b by 2 cos of a minus b by 2. Now cos of a minus cos b is actually completely different. This will give only sine, and actually there is another catch here. Cos of a minus cos b is written as 2 sine of a plus b by 2 sine of b minus a by 2. So just watch out for this part. This will be sine of b minus a by 2. It's not your familiar sine of a minus b by 2. It's actually the reverse, b minus a by 2. So I'll just erase this part. But just remember that it was sine of b minus a by 2. Now there are actually a few simple things you can actually make from here. Say sin of a plus b is sin a cos b plus cos a sin b, and sin of a minus b is sin a cos b minus cos a sin b. So actually multiplying these two equations, we get a very simple and actually useful result, which is sin of a plus b into sin of a minus b is equal to actually sin square a minus sin square b, or now sin square can be written as 1 minus cos square. So this is actually cos square b minus cos square a. And similarly, cos of a plus b into cos of a minus b can be written as cos square A. Now minus sin square B, it's not cos square B, it's minus sin square B, or it can be written as cos square B minus sin square A. So these were the sum and difference formulae, starting with sine of A plus B, sine of A minus B, cos A plus or minus B, similarly tan of plus or minus B. Then we move to sine A plus or minus sine B, which is these are now represented as product of two trigonometric functions, and then we just moved with this sine of A plus B. This is just a simple result. Actually, you can derive it very easily. Now moving to multiple angle formulae. Multiple angle formulae actually come from the sum and difference formulae. You just have to put B equal to A. So as the name itself suggests, it's multiple angle. Instead of just your argument say x or A or theta, you have 2A or 2x or 2 theta. So these are the multiple angle formulae. Again, as I said, these can be easily derived by just putting B equal to A in the say first equation. Similarly for cos A equal to B, and let's see what we get. So we get sine 2A is nothing but 2 sine A cos A. Similarly cos 2A, this is actually cos squared A minus sine squared A. Now here note that sine squared A can be again written as in terms of cos squared A as 1 minus cos squared A. So we get 2 cos squared A minus 1, and similarly writing in terms of sine we get, so it can be written in terms of only one trigonometric function. Now actually this is used in the reverse also to write say sine A. Sine A is nothing but 1 minus cos 2A by 2 and the square root of that. Similarly cos A can be written as 1 plus cos 2A by 2 and the square root. Now tan 2A can be written as 2 tan A by 1 minus tan squared of A. Remember the minus sign? You just have to put again B equal to A and you get 2 tan A by 1 minus tan squared A. Now these are just for 2A. You can similarly derive these are just for sine, cos and tan of 2A. You can similarly derive for say cotangent. Cotangent will be given as cot squared A minus 1 by 2 cot A. So it's just the opposite of this. Actually you can take the inverse of this. Cotangent A is nothing but 1 by tan 2A, and then dividing the whole thing by cot squared A will give you cot squared A minus 1 by 2 cot A for this. So this is just for the argument of 2A. Now similarly we can write for 3A. For 3A we get sin 3A is equal to 3 sin A minus 4 sin cube A. Cos 3A is 4 cos cube A minus 3 cos A, and tan 3A is 3 tan A minus tan cube A by 1 minus 3 tan squared A. Now these equations are also very important, and it's actually very easy to derive them as well. All you have to do is in the formula A plus B, you'll have to put B is equal to 2A. Just put B equal to 2A, and we are aware of the functions sin 2A, cos 2A and tan 2A. So from these formulae, sin 2A is 2 cos A, 2 sin A cos A, and then cos 2A is similarly, we can get these functions very easily. It's still better to remember these formulae, because these formulae usually come in the exams. You have to use their expansion, or sometimes you have to reduce them say 3 sin a minus 4 sin cube a as sine of 3a. So it's better to actually remember this. After actually argument of 3a, say 4a or 5a, these formulae are not usually supposed to be remembered, and they usually do not find their way into exams. Even if they come, it's actually pretty easy to, you are supposed to break it up in most of the questions and bring it to one of the forms of a or 2a. Now, once we are done with all this, then comes a triangle. Now, a triangle, trigonometry was invented for studying triangles. So, it's actually of paramount importance for triangles. But in triangles, we have one and very important condition, that being a plus b plus c equal to 180 degrees. That in degrees or pi radians. So, that gives us some of the most important formulae, and these, if you can remember, nice and good. Otherwise, you should know at least how to derive them, because they sometimes get very tricky. So I'll write down the formula here, and in the subsequent video lectures, I'll probably solve a few of the questions and show you how they are supposed to be say derived if you have enough time. So sine of a 2a plus 2b plus sine of 2c is equal to 4 sin a sin b sin c. Similarly, cos 2a plus cos 2b plus cos 2c is actually minus 1 minus 4 cos a cos b cos c. So these were actually 2a, 2b and 2c. Let's take the angles themselves. So sin a sin b plus sin c. This is actually 4 cos of a by 2 cos b by 2 cos c by 2. Similarly, cos of a plus cos b plus cos c is 1 plus 4 sin a by 2 sin b by 2 sin c by 2. Now, this is actually one of the next formula is one of the most important, not exactly formula, it's actually more of an identity. So this is one of the more important identities. Tan A plus tan B plus tan C is actually equal to just the product of the individual tangents. And similarly, tan of a by 2 is no plus here, actually it's multiplied. Tan of a by 2 tan of b by 2. So this repetitive addition, that means sin of b, tan of b by 2 into tan of c by 2 plus tan of c by 2 tan of a by 2 is also equal to 1, is equal to 1. So for a triangle or for any three angles which have a sum of 180 degrees, we have these conditional identities. Now let's move over to some non-standard angles. Now, usually, or rather, every trigonometry student should know the values of the trigonometric ratios for these angles: 0 degrees, 30 degrees, 45 degrees, 90 degrees. Now, all other angles, so these are the standard angles. Right. So, all other sorry, I missed one. That was actually 60 degrees. 60 degrees and 90 degrees. So, these are the 5 angles that are called the standard angles, and every student is supposed to just, they are actually not that difficult to memorize also. Now the non-standard angles are some of these angles. Non-standard angles. (15°), 18 degrees, and then say 22.5 degrees, 36 degrees. Now actually you need not memorize these formulae. Memorizing actually doesn't hurt it, but you should at least know, if you don't remember them, you remember their values, then you should at least know how to derive them. So I'll just do it for, say, sine 15 here, sine of 15 degrees. Now how do you find out sine 15 degrees? We use these formulae we just discussed. Say, the difference formula here, sine of a minus b. So what do I do here? I put b equal to, so I can write this as a will be my 45 and b will be 30, or this can be written as sine 45 cos 30 minus cos 45 sine 30. Now this is 1 by root 2, cos 30 is root 3 by 2, cos 45 is again 1 by root 2, sin 30 is 1 by 2. Or I get it this as root 3 minus 1 by 2 root 2. So this is sine 15. Similarly I can get the other. So all you need to remember are the sum and difference formula, and using that you can derive the multiple angle formulae. You can find out the conditional identities, and you can also find out the trigonometric ratios of these non-standard angles. Okay. So thank you so much for watching this video. In the next video we will be covering some of the typical examples and see how they are supposed to, how to solve them quickly or how to solve them. Thank you.